Have you ever felt like time is just flying by? Well, what if I told you there are places in the universe where time literally slows down? It's not science fiction. It's one of the most mind bending predictions of Albert Einstein's theory of general relativity, and we can see it happening right now out in the cosmos. Imagine two clocks perfectly synchronized. You keep one here on Earth, and you send the other on a journey near a supermassive galaxy, a cosmic giant billions of times more massive than our sun. When that clock returns, you'd find it has ticked slower than the one you kept. Less time has passed for it. Why? Because massive objects warp the very fabric of space-time around them. Think of space-time as a stretched out rubber sheet. If you place a small marble on it, it creates a tiny dip. That's like our Earth. But if you place a heavy bowling ball in the middle, it creates a deep, steep well. That's like a massive galaxy. The more massive the object, the deeper the curve it creates in space-time. For anything moving through this curved space, including light and time itself, the path is longer. So, for a planet orbiting a star in a distant, massive galaxy, time is literally passing more slowly than it is for us here in the Milky Way. This isn't just a theory. Astronomers have actually observed this phenomenon. It's called gravitational time dilation. They've studied the light from distant stars and found that its frequency is shifted, a direct consequence of time slowing down in the strong gravitational fields of their host galaxies. Let's take this a step further. What about the ultimate gravitational monsters? Black holes. At the edge of a black hole, the event horizon, the curvature of space-time, is so extreme that time, from an outside observer's perspective, would appear to stop completely. An astronaut falling in would experience their own time normally, but to us, they would seem frozen at the edge forever. So, what does this mean for us? Well, it reveals that our everyday experience of time as a constant, universal flow is just a small part of a much bigger, stranger picture. Time is relative. It depends on your speed and how close you are to a massive object. The universe is filled with countless time zones, not set by humans, but by the laws of physics and the distribution of mass. The next time you look up at the night sky, remember that you're not just looking across vast distances of space, but also across different currents of time. Out there, in the gravitational wells of colossal galaxies, clocks are ticking at a different rhythm. It's a beautiful, humbling reminder of how interconnected space and time truly are. Thank you so much for joining me on this journey through space-time. If you enjoyed this cosmic exploration, please hit that like button, subscribe for more adventures, and let me know in the comments what other mind-bending topics you'd like to explore. See you next time.